So if C1S means coated one side, I'll bet you'll never guess what C2S means. And that's a much more common type of paper these days. C2S is pretty standard for text and cover stock. Typically, you're going to want that. Most people like that. However, there are still times to use uncoated or one-side coated. And that is because you can't write uncoated paper. So if you're making postcards to sell on the street corner somewhere in a popular tourist destination, remember when people used to go on tours and to tourist places? Good times. The backside, or the front side may have the Golden Gate Bridge and a nice shiny gloss photograph. But the backside had better not be coated, because when you try to write on that with pencil or pen, you need to be able to write there to put the address on to send to your family somewhere else saying, look where I am. Can you believe I'm on vacation? Also, anything with forms wants to be uncoated. If you go in and sign a liability form and it's coated paper, that ink is just going to smear right back off. It's a little bit harder to dry ink uncoated on actually coated paper. Not to make it sound like I said uncoated. Coated paper has a longer drying time. It's more of a challenge even when printing, and it's easy to smear that ink. So anything that needs to be filled in with pen definitely wants to be uncoated. Likewise, there are some presses that can't print two sides. They really desperately need one side to be uncoated for their feed systems to actually hold on to the paper. That's older digital presses. Lastly, again, on the card things, if you're talking like mailing cards for greeting cards, your Hallmark type deals, those definitely want to be uncoated on the inside for the same reason. The outside can be shiny and have all sorts of gloss pictures on it, but the inside, where you write your heartfelt birthday, holiday, or I'm so sorry, get well soon message, definitely needs to be ready to accept pen. There's different ways of coating. There's blade coats, which applies a coating to paper and with a flexible steel blade, kind of like spatula or like a palette knife, scrapes it on. There's also cast coating, which is you apply a coating to the paper web while it's wet, and then when you dry it underneath a polished cylinder, the cylinder helps smooth it out. Not dependent on this is whether or not you do it inline or offline. Inline coating, called machine coating, happens on the paper making machine. That means that while it's coming off the Fourdrinier, while it's on that wire belt, it's already starting to get coated, and it comes off, and in the whole machine produces coated paper at the end. Done. Some other paper mills do offline coating, where their paper making machines make uncoated paper only. And then sometimes they take some of those rolls of uncoated paper over to a coating machine to add coating later. This lets you be more flexible with your paper making, because your machine is not single purpose, it's dual purpose. That way you just keep churning out rolls and rolls and rolls of paper. And as customers order coated, you take it to the special coater afterward. So uncoated stock is called offset stock. Offset stock is greater for a couple things. So coated paper definitely gives you better imagery production. If you're printing pictures, glossy photos and stuff, you really want coated paper. There's a attribute to paper called ink holdout, which is how well does the paper resist soaking the ink inside. The more the ink sits on the surface, the better off you are for good quality images. The more it soaks into the paper, the more you lose your vibrant color, and also the more it spreads out and your halftone dots get larger and blur with each other. So you lose definition on uncoated stock, depending on the holdout. So coated is definitely the best thing to print on, but it's expensive and it's slow to dry. So if you're printing in lots of books and it doesn't need high quality images, it's better to print it on uncoated. The absorbency of the paper will help dry the ink faster. It'll accept the ink better. There'll be less smearing, quicker drying, quicker to binding, quicker to getting them into that New York bestseller aisle at the grocery store. So we can all read the latest Tom Clancy book, which apparently they're still making, even though Tom Clancy is not with us anymore. Anyways, there's something called Coldset Printing. I have to say that direct mail is not necessarily done this way anymore, having done direct mail for 5 years, 6 years ago. Direct mail is often now done digitally, so you can do it variable data, and you can allow yourself to get personalized on it. But there's still the direct mail, like newspaper type ads. Think those newsprinty ads you get in the mailbox for grocery stores that tell you that steak's on sale this week, or come on to Aldi, we have bathrobes in addition to your groceries. Those sorts of things are still done this way. So Coldset means you do a high-speed web press, but you don't actually do any dry dry cleaning is in my head. You don't actually dry the ink. You just sometimes let it come on out. And you're hoping that the paper, by absorbing some of the moisture out of the ink, will dry it faster. This is for things where speed is more important than accuracy. I know actually it's one of the reasons newspapers have not done so well over the last decades as the internet has taken over as a news source. Because newspapers, although people like good looking newspapers, although people respond to good graphics and bright colored pictures, in the end, what matters is getting that story published quickly. The best news source is the one that gives you the story first. If you're telling us today's news tomorrow, you're losing. Doesn't matter how pretty it is. You made a better looking newspaper than the competition, but they broke the story, you lose. So newspapers and direct mail and things that want to get stuff done quickly, that's me snapping. They really want to make sure that speed is more important than anything else. They just print on paper that's going to absorb some of that moisture for them. Saves the time. Paperweights. I'm not talking about that thing you bought on vacation that has a miniature Golden Gate Bridge inside a glass dome and you can shake it and the fog floats up or whatever. We're talking about how you specify how thick paper is. Paper is defined by how much it weighs. No matter how you measure that weight, it's still defined by weight. Paper is sold by its weight. While you think of thickness, people do generally, or at some point, sorry, I'm tripping over my words again. When you get into thicker papers above 100-pound cover, they start measuring it by the caliper thickness. So they put a micrometer or a caliper on it and actually measure how thick the paper is in hundredths of an inch or thousands. Sorry, I think it's actually thousandths of an inch. But anyways, up until about 100-pound, which is equal to 10 points, which is 1/100th of an inch. Yeah, it is thousandths then. Up until that point, you measure by how much it weighs. And there's two ways to do this. One of them I don't necessarily love is basis weight. Basis weight is being done based on the weight of a standard size of paper and a quantity of that paper at the same time. If any of you dabble in or enjoy things like science and mathematics, like I do, though more as a hobby than a career, this bothers me. And I think it should bother you too, because whenever you're doing scientific testing or you're trying to figure out a mathematical equation, the best thing you can do is limit the number of variables. If you're testing out a new medicine, you don't want to give one person a diet of nothing but McDonald's food, and the other person only healthy fruits, vegetables, and rice, and the medicine to see what happens, because you have another factor going on there. You have dietary factors. One person is eating healthy and the other person is eating not healthy. And that's going to affect the outcome of your clinical trial, isn't it? Anyways, you want to try to eliminate variables so you know that what you're testing is only what you're getting. This is two variables and I don't like it. This means you're basing your defining feature. You're going to call this paper 20-pound paper, but it's based off both a determined size and a determined quantity, which would be fine if it was always apples to apples, but it is not. So we'll talk about some common paperweight categories here, and then we'll get into why this whole thing falls apart. So most of the time, everything we handle is called Techstock. It's the most common paper out there because, you know, one book has hundreds of sheets in it. And even if you have a bunch of postcards, there's not as many of them out there as there are pages and books in the world. So it's more common. Anyways, it's thin. You can handle it daily. You can use it and read it. And it does good things for the internal pages on books, mostly, honestly. It's thin, it's lighter weight. It doesn't need to be as durable as the cover, which is called Coverstock. It can just be there and read on a book, and then it's survivable, but it's not as stiff, not as thick. You don't want thick postcard thick pages throughout a book. Your book will be like 2 feet thick. Anyways, so those are Techstocks. Cover stocks are thicker paper for postcards, business cards, and covers of kind of soft cover books. Here we go. And this is where the basis weight drives me nuts. And you just have to kind of memorize your papers and what they feel like, because there's no intuitive way of knowing what it is based off the basis weight, because there's two variables. Here we go. Book papers. You measure a ream of 500 sheets of 25 by 38 inch paper. Coverstocks is measured for 500 sheets of 20 by 26 inch paper. So you talk about it in pound, like 20-pound bond is your standard copy paper you buy at Walmart to run through your at-home desktop printer. And most copies and forms, if you go to, keep wanting to call it Kinko's, man, I'm feeling kind of old here. If you go to FedEx office and you want to make photocopies, you get it done at Staples, it's going to be done on 20-pound, almost guaranteed. And that's your standard paper. And the pound means that 20 pounds is how much 500 sheets of that paper weighs at 25 by 38. Except that's not exactly true because that's not a book paper. That's a duplicator paper. We're gonna get to that later because yeah, that's not even true for 20 pound. So these pound is like 80-pound paper, 28-pound stock. They all have to do with this size. But cover stocks are sold in smaller sizes of paper because they're never meant for signatures. See, text paper or book paper is intended to print 8 sheets of 8.5 by 11 on it and then folded down into a book and cut. But cover stock is never meant to be folded that many times, so it's a smaller parent sheet. The size they sell it in is smaller, but you're still comparing the weight of 500 sheets, but they're different sizes. Do you see why this bothers me? Because you can't directly compare them. Sure, they call it 80 pounds because the 500 sheets of 25 by 38 inch paper weighs 80 pounds. But when you have a cover stock of the same weight and it's also 80 pounds and it's also 500 sheets, but the size is only 20 by 26, how do you compare those accurately? You have to mention that it's cover stock. There's a lot of things in here that make it a little bit too subjective for me. I don't love it because there's confusion here. In fact, 80-pound book is heavier and is thinner than 60-pound cover. So even though the number is bigger on the paper or on the text, it's still lighter than the 60-pound cover. And there's also weird convergences where some very thin cover stocks and lightweight cover stocks end up being thinner even and lighter weight than some heavier weight text stocks. When you take it to the extremes of each category, they overlap in weird ways. It drives me a little bit nuts. Because remember, you're comparing different size parent sheets. And unless you're familiar with the parent sheet size of all these papers, it's very difficult to know what is going to be what. Why do I hammer this into you? I trust you guys to figure it out and know it. But remember, printing is never just for yourself. If you're doing this professionally, you're producing jobs for clients. And clients are not going to know this. A random person who walks into a print shop or orders online is not going to understand the idea that if you take 500 sheets of this paper at a large size, it weighs this much, and the other one the same thing, but it's a different size. They're not going to understand that 60 pounds and 80 pounds are not directly compatible in this particular example here, or in other examples too. Anyways, it's just one of those things we have to find ways of explaining nicely to our clients so they understand what they're getting. Grammage. You know, the metric system ain't all bad. Grammage is a nice thing. It's less confusing, and this is something that became standard because of digital printing. I may have mentioned the fact in the past I'm a Xerox child, so Xerox here. Because of things like Xerox digital printing, they had to find a way to specify, and it may not be where it came from, but it's at least how it got popular in the US to specify grammage instead of just talking about basis weights. Instead of measuring the king's elbow to the king's middle finger to figure out how big something is, you have the metric system, which is a bit more universal to begin with. Anyways, grammage means you're going to weigh one sheet of paper, only one, so it's always the same quantity. I don't know if I mentioned, sometimes the other measuring systems, the basis and thicken on the really thick covers, sometimes they're measuring not 500 sheets, but less than that. Anyways, if you're doing grammage, you're talking about a single sheet of paper cut to the size of 1 square meter. If it's always one sheet and it's always the same size, that means there's only one variable, and that is the thickness and density of the paper. I said two things, didn't I? But in conjunction. Only the paper itself is the variable, not how you're measuring it. If you're always measuring the same way, you can compare them. So this is great. This got popular because it didn't used to matter when you're running an offset press. You can have this weird subjective language that's unique to printing. But when you get into running things on a digital press, you need a hard, fast, direct comparison. So the digital press knows how hot to heat the paper and how much electric charge to give it to attract the toner particles. And it needs a direct, comparable, apples to apples comparison, or it's not going to be able to do that. So this is where the GSM, you can see on the diagram here, it says GSM below the 70 pound. 104 GSM. That means grams per square meter. Sometimes it's GM to the second power, kind of like in math for squared. So no matter what, you're getting the same comparison. You're able to tell by grammage how heavy something is actually going to be.